everyone. Welcome to RKGIT Ghaziabad. This is Swati Singh standing before you to deliver my lecture on the topic logic gates. I am faculty in ECE department at RKGIT Ghaziabad in the Electronics and Communication Engineering department. Now coming on, what are logic gates, where they are used? See, we have electronics. What is electronics? It is basically the study of science and technology in which we study electron. The electronics word is coined from the two words. It is electron and mechanics. Mechanics means something which is in motion, right? So whenever electrons are in motion, they are studied under electronics. This electronics is of two types. One is analog electronics and the other one is digital electronics. In analog electronics, basically analog circuits are studied. In digital electronics, we study the digital circuits. Now, as of a human body, the basic building blocks are cells. Similarly, in digital circuits, the basic building blocks are logic gates, right? So we can say logic gates are basic building blocks of digital circuits, and in other words, it is a device that performs a Boolean function. Now, what is a Boolean function? It is a logical operation which is performed on one or more binary input that produces a single binary output. So, it works on one or more inputs, does some work. What work it does, we will study in the coming slides, and then it will produce a binary output. Now, what are the types of logic gates? Logic gates are classified as, they are basic gates like NOT gate, AND gate and OR gate. These three are known as basic gates. Next are derived gates. These are NAND gate, NOR gate, XOR and XNOR gate, right? Amongst these derived gates, these NAND and NOR gates are also known as universal gates. Why they are called universal gates? Because we can implement any Boolean function with the help of these two gates, or we can also implement any of these gates with the help of these gates. For example, we do not have the IC of AND gate, so we can make it using NAND gate, we can make it using NOR gate. In the coming class, I will define it, how it works. Next is types of gate. The very first gate we are going to study is NOT gate. NOT gate is also known as inverter gate. This is a symbol of NOT gate. In it, what it does is, it is a single input gate. We give it an input A. A can have two values. A is a binary variable, so it can have two values. It can have either 0 or it can have either as 1. It can have two values, 0 or 1, because we are studying digital. In digital, everything works in 0 and 1, either on or off. It has only two states, either on or off. When we are giving it A, it will process it as the output will be A bar. That means either A is 0 or A is 1. When 0 is given to this gate, it will give the output as 1. When 1 is given to this gate, it will give the output as 0. That means it is inverting the bits. Therefore, it is known as inverter gate. Now, in market, how we can purchase this gate? So, it is available in the form of IC, that is integrated circuit, with a specific number written on it, and that number is here 74. Here it is written 7404. So, whenever you want to purchase this NOT gate, you will specify the IC number, and that is 7404. This is how this IC looks like. Here it is a notch. You will place the notch on the left hand side, and from the notch, this pin, downward pin is pin number 1, then pin number 2. In total, it is a 14 pin IC, and at pin number 14, we will give the supply. At pin number 7, we will ground it. So, how many pins are left now? 12. And this gate has how many terminals it requires? It requires only two terminals, one for input and one for output. So, here we will give the input, and here we will obtain the output. So, similarly, this whole IC can contain how many gates? 6 gates. How? Because 2 pins are specified for ground and VCC, they are fixed. Now, 12 pins are remaining. Out of those 12 pins, we will give one for input, one for output. So, it means one gate will require 2 pins, and in total we have 12 pins. So, how many gates are possible? Only 6 gates are possible. So, in short we can say that the NOT gate IC, it has 6 gates. 7404 IC has 6 NOT gate in it, right. Next is second gate is AND gate. It is a gate which has 2 or more than 2 inputs. Say those inputs are A and B. A can have 2 values, either 0 or 1. Similarly, B can also have 2 values, either 0 or 1. So, we have the combinations, we will study now. Now, what this gate is doing, it is multiplying these two. We write it as, logically we write it as A and B. That means it is multiplying A and B, right. The expression, Boolean expression is Y A B. Taking on all the combination, because we have 2 variables, so we can have 4 combinations, 2 की power 2. That means 4 combination in total, means when A is 0, B can be 0, B can be 1. When A is 1, B can be 0, B can be 1. So, coming on to the output, this is a truth table. On the left hand side we write the inputs, on the right hand side we write the output. Now, 0 into 0, 0. 0 into 1, 1, sorry 0 into 1, 0, 1 into 0, 0, 1 into 1 will give you 1. You are just multiplying it. That means, if we give both the inputs as 0 and we put a LED here, it will not glow, right, because output is 0. If we switch on one input as 1, either A or B, the LED again will not glow, the LED which is placed at output terminal. Now, if we give it as 1 and 1, both the terminals, then the LED will glow. This gate is available in the market in the form of IC 7408. So, individual gate has a specific IC number. So, this is 7408 IC. Since it requires 3 terminals and we have only 12 pins left. So, in 12 pins and 3 terminals, that means this IC contains 12 divided by 3, that means 4 AND gates. So, it has 4 AND gates, like we will give the input at 1 and 2, A and B, and output Y is obtained at pin number 3. The next gate is OR gate. The symbol for OR gate is this one, again 2 input or more than 2 input, right. A can have 2 values A and B, A can have 2 values 0 or 1, B can have 2 values 0 and 1. Again the expression is A or B. So, we are ORing these 2 bits A and B. Now, what it does is, A is 0, B is 0, A is 0, B is 1. A is 1, B is 0, A is 1, B is 1. These are the overall all 4 possible combination which A and B can have. Now, 0 plus 0 will give you 0, 0 plus 1, 1, 1 plus 0 is 1. In Boolean, these gates follow Boolean algebra, right. That is another topic. The 1 plus 1 is here 1, right. So, in Boolean 1 plus 1 is 1, on the algebra on which these gates work. The IC number for OR gate right is 7432, and this is the pin diagram. Again it will contain 4 OR gates, 7th pin ground and 14th pin will be the supply. These were the 3 basic gates. Next is NAND gate. NAND gate means a gate which is a combination of AND gate plus NOT gate, right. So, NAND gate is AND gate plus NOT gate. So, we will put an AND gate and we will place a bubble over here. Bubble means inversion. The expression is AND gate A dot B का inversion. तो ये हो गया A B bar. Now, again we will take these inputs 0 0 0 1 1 0 and 1 1, multiply and complement. See, it is multiplying and complementing. So, 0 into 0 0 का उल्टा 1, 0 into 1 0, again 1, 1 into 0 0 1, 1 into 1 will give 1 and then 0, right. The IC number for NAND gate is 7400, and this is that IC, it looks like this, 7 pin ground 14, again it will contain 4 NAND gates. We will place those NAND gates here, right, and the direction of these gates are from left to right. Each and every IC, it is from left to right except NOR one, right. Next is NOR gate. NOR gate means first addition and then inversion. So, we will place a OR gate here and then we will put a bubble. Bubble means we are inverting the bits now. Again combination we will take as input 0 0 0 1, 1 0 and 1 1. Output will be 0 plus 0 will give you 0 and then you invert it. It will give you 1, 0 plus 1, 1, then inverted 0, 1 plus 0, 1, then inverted 0, 1 plus 1 will give you 1, then inverted 0, right. The IC number of NOR gate is 7402. This is how IC looks like. The change here is that the direction of gates are now from right to left. That means pin number 2, 3 we are giving input and output is obtained at pin number 1. Similarly, 5 and 6 we are giving the input, output is obtained at pin number 4. 8 and 9 we are giving the input, output is obtained at pin number 10. 11 and 12 we are giving the input, output is obtained at pin number 13. Next gate is XOR gate, yeah, that is full form of XOR is exclusive OR. The symbol looks like this, again 2 input, you will make a slanting line like curved line like this and then you will leave some space between these two. The expression is the way of denoting this is y is equal to a then plus a circle b. Now how to open this? This circle means circle and a plus sign means it means XOR operation. And what does that XOR operation really mean? That means a b bar plus a bar b means first variable into complement of second plus second variable into complement of second variable, first variable's complement into second variable. Again we have taken the input 0 0 0 1 1 0 1 1, right. Now to find the output we need a column of b bar, we need a column of a bar, right. So this table can be expanded, here a column of a bar can be made, a column of b bar can be made, then a into b bar, right, it will be taken as a product separately, then a bar b again separately and then we gonna add these two columns. So final answer what we get is 0 0 0 0 0 1 pe 1 1 0 1 and 1 1 pe 0, right. It is absolutely correct. Now from this table again and again we can't do this whole exercise, right. We can't do all these a then b bar then a bar and b and then multiply and then addition, right. So we can conclude something from this table and that is whenever the inputs are similar, like these two inputs are similar, it is 0 so it is also 0, it is 1 so it is also 1. So whenever these two inputs are similar the output is 0. That means XOR operation means similar input will give you 0 output and dissimilar input will give you 1 output, correct. The IC number for XOR is 7486. Again this IC looks like this and the gates are oriented from left to right. The last gate is XNOR gate. The symbol is same except that here is a bubble. The expression is a plus again a circle b and a hole, we put a bar, or it could be written as a and then a circle, inside the circle we place a dot, that is a XNOR b. To expand this expression it is AB plus A bar B bar. So we are going to make a column of A bar, we are going to make a column of B bar, we are going to multiply those two, we are going to multiply these two and then we are going to add them. So final answer what we get is 0 0 1 0 1 0 1 0 pe 0 and 1 1 pe 1. That means we can again conclude that is similar inputs will give you a 1 output, similar inputs give you 1 output, just opposite to that of XOR. Now the IC number for XNOR is 74266 and this is how that IC looks like. This one gate is oriented from left to right, this from right to left, again right to left and here left to right. So these were all the basic gates, the derived gates and amongst these also we have studied both universal gates NAND and NOR. Now next we will study how this NAND gate is working as a universal gate, that is how it is going to implement all the other gates. Suppose we have got only the IC of NAND gate, right, 7400, we are only having that IC and we have to make OR gate from that IC. So how we gonna make it? See we have only NAND gate, तो हमने क्या किया, NAND gate को हमने यहाँ पर ये A input था, अब हमने इसको यहाँ पर भी A दे दिया, right. So before studying this topic we should know some Boolean algebra theorems, right, which we gonna apply here. Like यहाँ पे हमने A दिया, यहाँ पर भी हमने A दिया, ये गेट क्या करता है, ये गेट करता है दोनों इनपुट्स को मल्टीप्लाई एंड देन उसका कॉम्प्लीमेंट. तो इसने इन दोनों को मल्टीप्लाई किया A इंटू A का बार एंड a इंटू a होता है बूलियन के हिसाब से a, दैट मीन्स ये हो गया a का बार, दैट मीन्स वी आर गिविंग a and we are getting a bar. So this NAND gate is working as a NOT gate. Second, how this NAND gate can work as AND gate? हमने सबसे पहले एक NAND gate लगाया with two inputs A and B. उसके बाद हमने इसके आगे AND gate कैसे होगा? AND gate होगा NAND plus NOT, लेकिन NOT भी कौन से वाला? NAND वाला, ये वाला. तो हमने NAND के आगे ये वाला गेट लगा दिया, राइट? तो यहाँ पे आ गया ए बी, इसने क्या किया? दोनों को मल्टीप्लाई किया और उसका कॉम्प्लीमेंट किया. तो यहाँ पे आ गया ए बी बार, यहाँ पर भी ए बी बार. इसने क्या किया? इन दोनों को मल्टीप्लाई एंड कॉम्प्लीमेंट, राइट? तो ये डबल कॉम्प्लीमेंट हो गया, राइट? तो यहाँ से ए बी बार डॉट ए बी बार अगेन होल का बार. तो ए बी बार को माइंड में अगर हम x मान लें तो ये क्या हो जाएगा? x इंटू एक्स का होल का बार हो जाएगा, x का बार, राइट? बार से बार कैंसिल, सो यू विल गेट ए बी. दैट इज ए बी इज व्हिच गेट? ए बी इज AND gate. Next is OR gate. OR gate means again we will use here 3 NAND gates. In the previous one, see, we were using 1 NAND gate. 1 NAND gate से बनता है NOT gate. 2 NAND gate से बनता है AND gate. So there is a hierarchy in this to study this topic, to understand this topic. Next हमें बनाना है OR gate. So we will use now 3 NAND gates, 1, 2 and 3. यहाँ पे हमने a दिया, तो ये कैसे काम कर रहा है? प्रीवियस वन, जैसे हमने a दिया इसको, तो यहाँ पर भी a, यहाँ पर भी a, दोनों को मल्टीप्लाई करके कॉम्प्लीमेंट, a इंटू a का कॉम्प्लीमेंट, करेक्ट? तो क्या होगा? a इंटू a विल बी a, दैट इज a का कॉम्प्लीमेंट. ये वाला चीज बिल्कुल प्रीवियस वाला सेम है, ये वाला, ठीक है? दैट मीन्स हम a देंगे इसको और दोनों टर्मिनल्स को ऐसे कनेक्ट कर देंगे, तो हमें यहाँ पे मिलेगा a बार. सिमिलरली यहाँ पे हमने इसको b दिया, तो यहाँ पे आ गया b बार. ये क्या करेगा? इन दोनों को मल्टीप्लाई करेगा, a बार डॉट b बार, और फिर उसका भी कॉम्प्लीमेंट कर देगा. तो हम लगाते हैं इसमें डी मॉर्गन्स थ्योरम, जिससे हम बड़े वाले बार को, सबसे ऊपर वाले को तोड़ देते हैं इन 2 पार्ट्स. तो वो आ जाता है a बार बार प्लस b बार बार. तो ये आ जाएगा क्या? a प्लस b. बार से बार वो, क्योंकि x बार का बार विल गिव यू x. तो ये आ गया a प्लस बी. और a प्लस बी किसका एक्सप्रेशन है? a प्लस बी एक्सप्रेशन है किसका? OR गेट का. तो यहाँ पे डी मॉर्गन्स लगती है. नेक्स्ट है, इसी से हमें बनाना है कौन सा? OR गेट से हमें NOR गेट, जो इसमें मैंने अभी आपको एक्सप्लेन किया, मैं नेक्स्ट स्लाइड में बताती हूँ. तो इसमें ये OR गेट था, तो अब इससे बनाना है NOR. तो आपने उस OR के सामने यहाँ से यहाँ तक ये OR है, ठीक है? प्रीवियस वन से इसको आप कंपेयर कर सकते हैं. 1, 2 and 3, 1, 2 and 3, यहाँ से यहाँ तक दिस इज वन इज OR गेट. उसके आगे आप NOT गेट लगा दो. NOT कौन से वाला? NAND वाला. तो क्या बन जाएगा? NOR गेट बन जाएगा, राइट? तो आपने यहाँ पे दिया a, करेक्ट? यहाँ पे आ गया a बार, ये हो गया b, तो यहाँ पे आ गया b इंटू b का बार b बार. यहाँ पे गया ये क्या करेगा? a बार डॉट b बार का होल का बार, ठीक है? उसके बाद हमने रेड वाले बड़े वाले बार को डी मॉर्गन से तोड़ दिया. और डी मॉर्गन थ्योरम क्या कहती है? कि द बड़े वाला बार, राइट, इट विल ब्रेक इनटू 2. वाई इंटू 2? क्योंकि यहाँ पे 2 टर्म्स हैं, राइट? a बार और b बार, एंड द साइन ऑफ मल्टीप्लीकेशन विल बिकम अ साइन ऑफ प्लस. द साइन विल इन्वर्ट. और बड़ा वाला बार 2 में टूट गया. 2 में इसलिए क्योंकि यहाँ पे 2 टर्म्स हैं, राइट? तो अब हमने इस वाले बड़े वाले को तोड़ दिया, तो अगेन ये 2 में टूट गया और यहाँ आ गया प्लस. अब a बार का बार क्या होता है? a. b बार का बार क्या हो गया? b. तो ये आ गया a प्लस बी. तो प्रीवियस स्लाइड में ये जो a प्लस बी आया था, वो यहाँ पे मैंने आपको एक्सप्लेन कर दिया a प्लस बी कैसे आया, राइट? अब यहाँ पर a प्लस बी गया, यहाँ पे a प्लस बी गया, तो इसने क्या किया? दोनों को मल्टीप्लाई इन्वर्ट. तो ये यहाँ से समझ लो, a प्लस बी को आप माइंड में एक टर्म मान लीजिए, दैट इज कैपिटल X, राइट? कैपिटल X. अगर आप कैपिटल X ऐसी NAND गेट को देते हो जो यहाँ पर, जिसके दोनों टर्मिनल्स पे x जा रहा है, तो यहाँ पे क्या मिलेगा? x का बार, बिकॉज इट इज एक्टिंग एज नॉट गेट. तो ये हो गया आपका a प्लस बी का बार. और ये किसका वो है? एक्सप्रेशन है. दिस इज एक्सप्रेशन फॉर NOR गेट, राइट? एंड दिस इज द सिंबल. नेक्स्ट है, हाउ NAND गेट कैन वर्क एज XOR गेट, राइट? तो इसमें हम अभी तक हमने एक NAND गेट से बनाया, NOT गेट तो सिंगल गेट यूज़ किया. NAND गेट से AND गेट बनाया, 2 हमने NAND गेट यूज़ करे. फिर हमने NAND से OR बनाया, 3 करे. NAND से NOR बनाया 4 करे, अब NAND से हमें XOR बनाना है, तो अब हम 5 करेंगे, राइट, 1 2 3 4, और इसके बाद यहाँ पे 4 से काम चल सकता है, अभी इसके बाद ना हम यहाँ पे अगले वाले में 5 लगा देंगे। तो देखो क्या करना है, यहाँ पे हमने गेट कम कर लिया, यहाँ से आ गया A, यहाँ से आ गया B, राइट। अब इसने क्या किया, इस गेट ने इन दोनों को मल्टीप्लाई किया और कॉम्प्लीमेंट कर दिया, राइट, इन दोनों को मल्टीप्लाई करके कॉम्प्लीमेंट, यहाँ से क्या आ गया A, यहाँ पे A आया सिग्नल, यू शुड नो द सिग्नल एट ईच एंड एवरी टर्मिनल, यहाँ पे आ गया A B बार, करेक्ट, यहाँ पे ये सिग्नल आ गया, A डॉट B बार यहाँ पर भी आ गया, और यहाँ पे आ गया आपका B, राइट। अब ये गेट क्या करेगा, दोनों इनपुट्स को मल्टीप्लाई करेगा और फिर इन्वर्ट कर देगा, मतलब A को मल्टीप्लाई करेगा इसके साथ A डॉट B का बार और फिर उसको इन्वर्ट कर देगा, राइट। अब इसको डी मॉर्गन से हम तोड़ लेंगे, जब हमने डी मॉर्गन से तोड़ लिया इसको, तो बड़े वाला बार विल ब्रेक इनटू 2, राइट। पहले हमने अंदर वाला बार तोड़ा, A डॉट B का बार, इनर बार को तोड़ दिया, तो यहाँ से ये आ गया, राइट, इट विल ब्रेक इनटू 2, मल्टीप्लीकेशन विल बिकम प्लस, राइट। फिर हमने इसको खोल दिया, A इंटू A बार क्या हो जाएगा 0, और यहाँ पे A इंटू B बार रह जाएगा, तो A इंटू B बार का बार, करेक्ट। ऐसे यहाँ पर हमने इसको सॉल्व किया, बिल्कुल सिमिलर ऐसे ही इसमें भी हमने अंदर वाले को तोड़ दिया, यहाँ पे आ गया A बार प्लस B बार, सही। उसके बाद हमने ये करा, तो ये आ गया A बार इंटू B और B इंटू B बार हो गया हमारा 0। फिर आगे आप इसको सॉल्व करेंगे तो ये क्या करेगा, इन दोनों आंसर्स को मल्टीप्लाई एंड कॉम्प्लीमेंट, तो यू विल गेट व्हाट, एक्सप्रेशन फॉर XOR gate, that is AB bar plus A bar B. नेक्स्ट इज XNOR गेट। अब लगेंगे आपके यहाँ पर 1 2 3 4 5 गेट, मतलब ये XOR ऑपरेशन के बाद अगर आप XOR के बाद नॉट लगा देते हो, कौन से वाला नॉट, NAND वाला नॉट, तो बन जाता है आपका कौन सा, XNOR गेट, राइट। तो ये इसके एक्सप्रेशन है यहाँ से यहाँ तक बिल्कुल सेम, और जब यहाँ पे जो एक्सप्रेशन है उसको हम इन्वर्ट कर देते हैं, यहाँ पे हम देते हैं, तो ये इसको कॉम्प्लीमेंट करेगा। तो यहाँ तक ये क्या था, XOR के आगे क्या लगा दिया, नॉट, नॉट कौन से वाला, NAND वाला, तो मिल गया आपको XNOR ऑपरेशन, दैट इज AB प्लस A बार B बार, राइट। तो दिस इज ऑल अबाउट लॉजिक गेट्स। So this is all about logic gates, right? It was a basic just a review of all those logic gates and the fundamentals of logic gates and the NAND gate, right? How NAND gate is working as a universal gate. So I hope this lecture is fruitful to all of you. Thank you so much.